Then you can also do some book problems, like totally creative. So turn your book to 5.4. I don't know the page, so once somebody finds, what is it? There you go, 388. Perfect. And there's a lot of log stuff that they have in there. We're not going to do hardly half of it, probably. There's no winner. Oh, there we go. You will need calculators. If you don't have calculators, you can grab them around you. Cameron's napping. All right, so quick review of law. Oh, actually, I think we can just use the book page for this thing. Oh, okay. My board is super slow. Like, even when I write something, it takes forever for it to. I want you to change that into an exponent, base exponent, all that stuff, all that fun stuff. Super fun. You'll know how to do. I mean, even though we're getting into a new chapter and it does get complex, the first few things are not that bad.
Is this it?
You guys can compare because I got to go get the copies.
Yeah. They're not friends. I'm driving. I'm driving.
So we will work from the book and from worksheets again. The book just doesn't give that many columns that are like the ones that I want you to.
You know, $1,000.
Yeah, that's what the game.
Never mind, it's just trades only.
There you go.
I don't have anything negative beyond that. I can't even drive.
I was thinking.
Are you gonna Tamagotchi for $15?
Camera, there you go.
I was thinking
There you
either
go.
trade or just the body. No.
It's almost together. I just give you one room, but no.
It's a picture.
Figure out.
It's your home.
Facebook.
Place.
1, 4. So we've talked about the relationship that is the go-to relationship for logs. Now we're putting a specific name to it, sort of. And we might have mentioned before. I actually don't know if we have or not. It's the one-to-one relationship for logs. Oh, oh, nope. First try it. So So what's that mean? Lucky out.
What?
What's that mean?
This?
Yeah.
A
Good chance.
to the power of y equals x.
So we said if we just understand that's really what logs are, and we can kind of get rid of the logs. I'm sorry, yeah, get rid of the log function. Then we can make it an exponent problem, and we're a little better at exponent problems. So that's one thing that you need to keep in mind again today. Let's see, what else did we do that was, oh, so we also said when we solve an equation out for log,
Oh,
let's record.
yeah.
Let's do that,
That's
right?
fine.
Right? Let's do that. I know it wasn't, and I still remember it. No thanks to you guys. Oh, are you serious? I'm actually still recording, so I've been recording all day. So
You just don't have the transcription.
yeah, how does that work? Not recording.
Start transcription right under.
If I don't care about the transcription, how do I know for sure that it's recording? That's what I'm worried
You
about.
have the red line.
I guess I just have to. Well, that's just sharing. That's why that's in red. That just means I shared it. Oh yeah, there we go. Okay, so we're good. Yeah, I don't care about the transcription. I mean, I guess maybe I should. I doubt any of you have ever even gone back and looked at it.
I'm going to care about it when I look back.
Right. Promises, promises. Promises, promises.
I probably won't because my ESP certification's next week. And then I'll be gone.
We'll see. Got to pass it first. All right. So the other thing we said is when you solve out an equation, so if we have log base 3, x equals 4, and then we have a 2. So we said if we have something like that, looks kind of complex, but really we could think of this. How am I going to do that? I know, right? There's not. I wish there were a fast way to do it. There's really not. So we're just going to do this. So I could really just say, well, I'm going to treat this right here as a variable. I'm just going to say, well, that's an unknown number, which it is an unknown number. There are ways to solve for it, but right now it's an unknown number. So we're just going to, that whole thing is x. So we said, okay, well, if that's the case, and we're just treating it as x, and I want to solve for x first, what do? I divide by 2, which will give me x equals this big x thing. So this big X thing would just equal 2. Well, now I can go backwards and bring into play. Hopefully this, yeah, there we go. Super slow, but it worked. Now I can come back and say, well, that X wasn't really X anymore. That X was log base 3 of X. So I can replace that with log base 3 of X equals 2. And now I know how to solve it. What does that mean? Same thing we just did.
3 to the power of 2 equals x.
So 3 to the power of 2 equals x. So therefore x equals. So again, we treat log base something of a variable.
Not the exact same.
The answer was not, it was 3 squared equals 9, but it was not. Like, I mean, these numbers were just different and they just divided out to 2. So again, as long as you understand that that's just like if it were just x here, this is some I don't know that number, so I can't figure out the log table. So just treat the whole thing like it. What other? And then I'm not gonna actually. I think we have to worry about the product of quotient rule. Yeah, that's not in here. So I think that's all the review we'll need for today. Oh no, one more thing. What was the other thing that I made you memorize? So I want you to solve for that. We say it out loud. Solve for that. Well, unless you're it is.
Doesn't feel like algebra. It feels like math.
I mean, they definitely use a lot. Well, I went into Miss Pinster's room yesterday after school. She was doing a lot of the same exact stuff that we're doing with the time.
But this is supposed to be out.
Actually, what we do today, I think gets into what we did log. I like to ask this week. What she was doing is more like what we were doing today. I need to get her worksheet. Actually, I don't know why I looked for stuff I should just grab it. I will do that. All right, so what do we do to solve, evaluate? Like you can come up with an answer to that. You have to round it off, but you can come up with an answer. What do we do?
Oh, you have to eat.
We can't. Do that, I guess. There's another way to do it. How do you solve that?
Same base.
Well, you can't. That's the thing. If we had one that I said without a calculator, that's when you'd be able to do it. I just say evaluate, and you're like, yeah, I can't. Again, it never hurts to try that. So let's estimate. We should be able to estimate it though. What would x be approximately? A little bit higher than 2, right? Because 2 would get us to 16. So we know x is going to be approximately, I would say 2.1, right? Or something like that. So again, did you do that with a calculator? What's the function you? Did they raise it to an unknowns? Oh, you randomly plugged in numbers or something. So again, we could make a pretty good estimate, but I want to know to like the 100th place. So I got to be able to like do the math on it to get that. What was the rule we learned? I know you already said. Christina, what'd you say? What were you saying there? Hand up. Yeah, that was your hand. I saw your hand. I saw the hand.
Yes.
You plugged and played?
Yeah.
All right, did you get it to the 100ths? 2.044, you think? All right. Oh, so you just kept plugging in the next one. All right. What was the method? I will make you show work for log, so you will unfortunately not be able to do that. I'll give you partial information. Actually, it's a much easier way to do it. All right. That was that formula you were all supposed to memorize for the quiz. Now I'm a little worried about the grading of the quiz. So I've forgotten it already. We just said log of the big number divided by log of the base. So if you say log of 17, you have to close the parentheses probably. Divided by log 4. And we're choosing a base of 10 because we can choose whatever base we want with that change of base formula. But 10 is the only log we can take into calculus. That's the only log that's happening. Or we could have done natural log. Where are you going?
I was actually. Yeah.
Really? Really, right is a process, not a result. That's what you guys think. That's what you guys think. I want the full thing. That's what I should make you do on the quiz. I'll make you round it off to the 1 millionth place. I'm going to make you round it off to the 1 millionth place on the quiz. So you can plug and play all you want, but it might take a while. Good idea.
I just walk out of here crying.
Not if you know the formula, you won't, because you'll just do it. It'll give you all the digits you need if you do the formula. It's not like it's a real difficult formula. You take the log of that divided by the log of that. I mean, come on. Come on, people.
Simple addition makes my brain hurt.
Come on, people.
This is algebra calculus. What is the Pythagorean theorem?
All right, so that's one you needed to know. So between those three things, that's really, I think, all we need today, other than I'll add some new stuff in that we haven't really done before. How? All right, let's do this. One more quick thing.
115, I have to leave this ago.
That's what you do. How do I solve that?
Hey,
Yeah, square root. Well, not square root.
I mean, that's really
Cube, right? And again, it would be the same thing if I had the an x plus 1 under there. So here's the other key to remember. Well, there's only one, but we're not solving. I mean, you can solve. So whatever you do to one side of an equation, you have to do to the other side, right? And the same is true if I said, I can do whatever I want to one side as long as I do that same thing to the other side, right? Keep that in mind. Whatever, I can do whatever I want to one. Like, I think when we changed, sometimes when we changed, when we were trying to find like a common denominator, sometimes we multiplied it by a version of 1, like x over 1, or x plus 1 over x plus 1 or something when we were trying to find common denominators. So just remember, whatever you do on one side of an equation, you can do it on the other, which means I can choose to do whatever I want as long as I do it on both sides. So keep that in mind as well when you're going through. All right. So now let's look at.
I know that because I have to cook.
I guess that's okay. I don't think anybody was waiting. Here's the path. All right. So look at the example 1 stuff. We're not going to necessarily go over all of those. The first one is an example of what actually Rachel was saying. Oh, wait. If we have that 2x to the 32nd, that's where we would say, well, maybe I can come up with the same base. And then that would make it super easy to compare exponents, right? If I could just make this 2 to some power, then I just compare the exponents with each other, and it's a simple algebraic equation then, not any real complex math. So sure enough, in this one, 2 to the x equals what? 5th, is that right? 5th. So now I can just say, okay, well, in order for those to be the same number, the exponents have to equal each other, which means x has to equal 5. So that's called a one-to-one comparison, but that's a way that you can solve, is that you can kind of isolate the problem down to just comparing one piece to one piece. Like one thing. We have the same. And that's what we've been doing for a while. Like that's not super new. Kind of the same thing on the next one. So, well, I'm really extending this way out. That's fine. What's the next one say? Law, natural. That's a natural log, by the way, the ln. What is it? Natural log of what? The one that's right after that one that we just did in the book. The example 1. Oh. So again, if we can figure out a way to get the same base on both sides of the equal sign, so we can just compare. Now it's not an exponent yet, but we could change it. Turns out we don't need to in this. But if I could say, well, I got natural log of x here, natural log of 3 there. If I said, well, what about, and again, you just got to play around with it and do some practice problems. What if I added natural log to both sides, natural log of 3, if I added this unknown here to the other side? Actually, something we could solve for in a calculator too, but this would be without a calculator. So now, if I need to know what x is, the only way those can be equal is if x is 3. I'm taking the natural log of 3 here, and I want that to be equal to whatever this comes out to be, then I've got to take the natural log of 3. Again, that's 1-to-1. I've made it a natural log and a natural log, and then I'm just comparing the 3 to the x. If it would have been x plus 4 in here, then I would just be able to say x plus 4 equals 3. It has to be the same number, same power number. So again, kind of the same thing in the next one. We're changing it to the same base. All right, so let's go to D. D is where it gets a little tricky. Hold that thought. I'm going to do something really quickly, so I'm really wasting time. What in the world? There. Oh. Ah, that's fine. Hold that. Hold it. There you go. I had it zoomed out way too much. Fix that. There we go. Should work. I hope. There we go. All right. I'll fix that. So next, E or D is e to the x equals 7. Here's where it gets a little more complex. E to the 7, what's it equal? E to the 7 equals what? Oh no, e to the x equals 7. E to the x equals 7. That's why I couldn't remember. All right. So E we said is just a constant. It's like pi, sort of. It means a totally different thing, but it's like pi. Pi is a symbol that is actually a number. E is a letter, a variable, but it really is a number. It's not an unknown variable. E is a constant number. So we're taking that constant number, raising it to some power, and we're getting 7. Now you could plug and play on this one also, because you can find E out. So just so you know, for SAT type stuff.
It's a second offside.
Well, that's I guess so. So you have to say like e to the x and raise it to the first power. Let's try that. Yeah, there you go. So again, there's an ln button on the left above that e to the x. So that's the constant that e is 2.71818. I'm sorry, 1828, 1828, and it doesn't actually repeat forever. It winds up changing, even though it doesn't look like that. So that's a constant number. So you could actually plug that number in like we just did. Keep plugging in different exponents for x until you got as close to 7 as you can. So same strategy somebody used on the other one, you could do that. We're going to do it a slightly different way. Here's where the algebra. So those of you that were good at algebra probably get pretty good at this.
Yeah.
I said whatever I want, right? To both sides of an equation, as long as I do it to both sides. So there's a property, so everybody pay attention. You need to know this potentially in about an hour and 10 minutes. So there's a property of E, well, property we learned that's about E. Quick reminder, the natural log is the same thing as log base E. That's the same thing. They mean the same thing. So if we're taking the log with that E as a constant as the base, that's where that natural log function came from. It's the same thing. There's no reason why we just made it down. So what I could do is I could take the natural log of e to the x. If I do that on one side, I got to take the natural log of the other side, 7. Again, that's just a function of I can do whatever I want to both sides. And I'm choosing the natural log for a reason. Because what does the natural log mean, we just said? Well, we're not going to use that yet. But we will. First, let's focus on the left side. So what can I change that would maybe make a little more sense on the left? That natural log thing is a little weird. But we're more familiar with log, right? So what can I change the left to? Log base what?
10.
Nope. Because I can't just do change of base yet. It's not set up to do that.
Log base.
That, right? I could change it to log base e of e to the x. What did we say about that?
These cancel out.
Do, right? So we're just going to be, oh, and then I could write log base e over here of 7. I'm not going to change that side, though, because we don't need to on that side. Doesn't help me cancel anything out. I didn't do anything to this side. I just changed what that means. So it's like substitution in doing math. So I don't need doing math, right? Now then, we said if we have the base and we're taking that same number, that cancels out. Or you could also think of it as, if we're just looking at this, how do you read that if that's all we had? Well, we're going to get rid of the log. What do? How do we, like, ignore that that's over there? We're not using that yet. How would I read that? That means what? E to some power, right? Equals e to the x, right? Well, then it's x. I mean, it's the same power. It is x. So again, whatever you want to remember, if you have a base and a big number that are the same, then you just have the exponent left over. If you want to understand that you could take this raised to some power equals that e to the x, so therefore it has to be the same variable. Whatever you need to do to understand that left side, when I take the natural log of e to some power, I'm just left with the exponent. So now we can use the calculator and say, okay, well, if I'm solving for x and I now just got rid of everything and all that I have, then x equals the natural log of 7. So if you'll go ahead and take the natural log of 7, what did that come out to be? And you will be using the calculator a lot in your next videos.
I'm so smart. I did that. I was in hospital. But I think I was watching it. That wasn't even
Yeah, it's not like that.
you don't think about it. That's kind of a cover.
Wait, not the one yesterday or last week.
The other one.
Didn't I just?
No, you did. That's why I
Oh,
asked.
yeah.
Can I look at it? My time.
Yeah, not right now. You don't have time.
Okay.
Well, I'm going to give these worksheets to you, and then you're just going to work on it. I'm going to help you do problems here. Oh, so is that the answer? Oh.
How do you use your calculator?
Oh, they didn't do it. No, I was looking at the book. They just left it at x equals the log of natural log of 7. All right. So again, if you'll notice.
So we used another percent. What says to leave it on?
Well, no, you would have to solve it out. They're just rewriting it. I mean, again, I don't care if you leave. I mean, it's not like it's that. Seriously, punch in on this. We just did that extra step for nothing. I like a whole bunch of extra.
Yeah, that extra step I could have used to figure out work on my next problem.
All right, so I don't really know how to explain this next piece to you. I know, right? I don't know how to really explain this, why this works, but it's kind of the same. It's the same concept of whatever you do on one side of an equation, you can do on the other. So look at E now. E is a little tricky. So we have the natural log of x equals -3, right? So I'm going to read this again as I'm going to change it to log base e of x. Again, I didn't do math when I did that, so I don't need to do anything on the right. I just changed the format or the whatever it'd be called. They're the same thing. I didn't do any math to it. Well, now, and again, I don't know how to explain what you're doing, but if I wanted to, I could take both sides and make the raise, like I could raise, like again, I don't know. I'm basic. It has to do with the one-to-one relationship. I'm still just comparing these two things, right? Those two things are equal. So if I set E as my base, again, those two things are still equal, right? I think we can all understand that piece of it. Like I didn't change what I'm comparing.
Yeah, but why?
Right? Well, because what does that equal on the left? X, right? We now can say, well, that's going to cancel out with that, and that's how I get the X isolate. Yeah, I don't know why they went through it like that in the book, but yeah. Yeah, I don't know why they're doing it this way. I'm showing you a theorem more than anything. Like, I don't know if you ever actually need this theorem, but I want you to understand that one of the ways to get rid of, if you have the log base E of X, one of the ways to get rid of that would be to raise E to that power. We don't need, again, I don't think I'm going to give you anything that's complex. I'm going through some stuff before SAT, ACT stuff. So yeah, why they're going through that, I don't know if that's what they're telling you the answer is. Just we know that from the most basic stuff we've done. E raised to that power equals X. So maybe I don't know. I don't know why they're doing that. Maybe if this was X plus 4, you would need to do it the way we're doing it in order to be able to solve, maybe something like that. So the fact that it's X maybe makes it possible to do it a couple of different ways. I guess we'll find out when we do some practice problems if you have to use this or not. So yeah, so if I do that, I get that. That on the left side is X, and then we're just left with that still on the right. So that's why they did that.
If you don't understand this, why do you think you can understand this? If you make
Well, I don't understand when you would use it. I understand what they're doing. I don't know why they did it. Like Janelle was saying, I mean, think about it. We know from our most basic exponent stuff, right? E raised to the negative third power equals X. I don't know why they did all those other steps in between. My guess is there's some problems where you have to do it. We didn't have to do that one, but that doesn't mean there aren't some more complex problems where this is the only way you can do it. Well, if they come up, then I'll see how rough I think they are, and if I think they're too difficult, then I won't fix it. Well, you thought that punching in log of 7 was too much. Well, that doesn't.
No.
You really carry no weight with me whatsoever. You think.
Not too long to do
By saying that, I think I did say that one.
So you said
Pretty sure I said that. Ellen. So pretty sure. So anyway, that I'm just explaining what they're doing in the book. Why they're doing it, I can't. Let's see. So we did E. Oh, F is the same thing. They're just raising it to the, again, I don't know why they're doing it. Log base 10 of X equals -1. Well, that means 10 raised to the -1 is X. I don't know why they're choosing to raise everything, like make 10 the base, raise it. My guess is maybe that comes into play down the road and you'll probably have to do that. And again, log base 3 of X equals 4. We can raise it to make that the exponent on both sides, the 4 and the log base 3 of X to get rid of the log part, but really we could have just said 3 raised to the 4th power is X also. So I don't know why they're doing those. We're going to definitely focus on the one-to-one stuff up above a lot more than make sure you understand those. So with that in mind, try to do, and I don't care how you do them, try to do A through D. Not super, at least first glance, they don't look super difficult. D is the only one that you should have any trouble with. I mean, D, I guess, is you got to think about it, but C, I think, is hardest, then D, then D, D. I'm going to do attendance while you guys are wrapping those up. Did you hear the ones, Christina? I know you just walked back in. Oh, your egg. Oh, no, none of those are the exit. Your exit ticket is coming up in